Okay.
Jonan Scheffler is a fantastic Rubyist and Ruby friend and Ruby community leader. Joan and I actually first met several years ago at RubyConf New Orleans, where I was coming in as a bootcamp student from the Flatiron School in New York. And Jonan was a RubyConf mentor. And he was my mentor, one of my mentors, which was awesome. And since then, Jonan has been he's everywhere in the Ruby community. He is actually professionally the director of developer relations at New Relic, which is recently I heard he mentioned all their products are open source at this point, which is pretty cool. And he lives out in the Great Pacific Northwest. So we actually want to invite Jonan to come and join us on the stage. I'm going to make you a presenter. You should be here. If you put your camera on, Jonan, you should welcome. Hey, Jonan, welcome to Israel.rb. You didn't have to take a plane ride. You didn't have to
right? That's
anything. You're just here.
Yeah, I've done
welcome
that.
To Tel Aviv.
Thank you.
I'm going to get off the stage and let you do your stuff. And there's my little kid behind me. There we go.
Okay, so hello, Tel Aviv, and also everyone else around the world. I visited Tel Aviv a few years ago for a conference where I was speaking, and I am in love with Tel Aviv. There's a whole song about that we sang at karaoke that I'm not going to pretend, but it's Ya Habibi Tel Aviv song. Everyone was singing. I love the city. I love the culture of people there. It reminds me very much of Portland. And I hope to someday visit again, but it looks like it's going to be rather a long time. So I'm going to try and share my screen here and give you a little more detail about myself. Oh, I can share an application window. Well, let me try this then. Let's see if I can do this. If I go and I play this thing. That's not how I do it. Well, okay, I'm just going to go ahead and share my whole screen, and I'll learn how to do this thing later. There is a way in Keynote now, apparently, to share a windowed view, but I'm too old school for all that fanciness. So you just get the nested view, and then my presentation instead. And now you should just be seeing my presentation, but there's no way for me to hear anyone and tell me that that is in fact the case.
We see just a black screen.
That's not going to do. Huh.
Did you tried the share screen button at the bottom?
I did, but let me.
I've actually Ben, do you have can you walk him through it?
Yeah, so if you click share screen, it should prompt you. Yeah, we saw your current screen. We saw the screen where you're on with Remo. So if you click share screen, you should see an array of options of screens, and you probably want to share the Keynote screen, right?
Yeah.
You see, clicked on Keynote?
Clicking on Keynote, and I'm doing this, and then I'm, okay.
Let's see what happens.
Let's try it again here. I'll just, I'm sharing Keynote here. But now you're just seeing my actual presentation, right?
We do, but you can play this presentation, right?
And now you see it properly?
Now we see it properly. I'm going to get off now. This is perfect.
Okay, great.
Okay.
Sorry about the confusion. This is a presentation called Rubybender about metaprogramming. And metaprogramming is very near and dear to my heart. So I want to explain why real quick. You can find me on Twitter, by the way, as The Jonan Show. You have my Twitter handle down there at the bottom. This is my COVID-19 isolation hair. It has gotten significantly more out of control since then, as you just saw. I am almost desperate enough to learn how to cut my own hair, but I'm not quite there yet. I was originally a poker dealer many years ago. I actually had a lot of jobs in previous lives, maybe about 10 before I was 30, and then I came to tech. And the last one that I had before I became a programmer was in a poker room. I was dealing poker. And I got into this boot camp called Hungry Academy. Hungry Academy was one of the first boot camps, and it was a paid program. I was very fortunate to be accepted. I was one of 24 people who they took into this program, and they paid us all engineering salaries to learn to be engineers. I don't think that program exists anymore. Someday I hope to rebuild it. There is a plan that I'm hatching in retirement to someday rebuild Hungry Academy, a bootcamp that can pay people to attend. So they paid us to come and learn how to code, and then they gave us jobs. And by they, I mean Living Social. This was a program run by Living Social. A couple of people, Jeff Kashmir and Chad Fowler. Chad Fowler wrote several books, very famous Rubyist. I'm sure he was one of the founders of RubyConf, actually. The first RubyConf was put on by Chad Fowler and friends. So Chad Fowler was the CTO at Living Social. He had hired most of the Rubyists he knew personally and thought, hey, wouldn't it be neat if we made some more Rubyists? So that begat me and my career in software. And I went from Living Social to go and work at New Relic, where I worked on the Ruby agent. And the New Relic Ruby agent is the gem that you install in your application in order to automatically instrument all of the things in the New Relic platform. So New Relic, for those who are entirely unaware, is a way for you to monitor your applications and your infrastructure. It will, using a series of libraries that are available in any number of languages, and we have a server monitoring agent as well, and serverless and like that. All of these little bits of code that you install into your application will then give us visibility into what's happening inside of there. So for example, the New Relic Ruby agent, you would install inside of your Rails application, and it will tell you how long your page loads take and how much of that time is made up by your database, retrieving data from your database, how many times you go out to the database in a given request. It's a lot of information that it is surprising to be able to get just by installing a gem. And the way that we achieve that is by using rather a lot of metaprogramming. So metaprogramming is one of those things that you don't usually have cause to use in your day-to-day life as a Rubyist. If you're using a lot of metaprogramming, you're probably overcomplicating your life significantly. It's not something you should be using without really understanding it. And I hope that at the end of this presentation, you will understand it a little bit more, or at least be motivated to Google it so that you understand it a little bit more. I'm in fact quite confident that this presentation is going to confuse you, because it actually confuses me. But I've been doing this for about 5 years, I guess, in the metaprogramming world. I've been writing Ruby for about 10. But when I first, I guess I'm going to have to back that up. It was 8 years ago that I got my job at New Relic. And I did metaprogramming the whole time I was there. And then I went off to a company called Heroku. And I was at Heroku for 4.5 years, and have just recently made my way back around to New Relic. So I'm back at New Relic. This time I'm doing developer relations. That was what I did when I was at Heroku. I got to go to a lot of conferences and hang out in beautiful places like Tel Aviv. And now I'm back at New Relic to continue relating to all of the developers. I'm certain that most of you, apparently being developer advocates yourselves, understand the field of developer relations. New Relic is going to do things a little bit differently, but we're not going to talk about that just yet. It'll take me a few months to get the program ready. So I'm back at New Relic. That's where I learned to metaprogram. And today we're all going to learn to metaprogram together. We're going to start way at the beginning with this, right? We have a baby, a human, and we make it with human.new, right? This is us creating an instance of a baby. That baby comes from this blueprint, right? This here being our DNA, we make a human. And this is the DNA, right? So when we make an instance of a human, that baby comes with the methods that we define on human, right? This, I think, probably does not come as a surprise to anybody. And we would say that the human on the left is an instance. I'm using an instance variable to denote our instance of human as distinct from human. So what I want to point out, and I really want you to try and take away from this talk, is simply this, that everything in Ruby is an object, right? So a lot of people have this idea that human in this case is the object. And then I'm sorry, at human is the object. And capital H human is the way that we make the object. Those are both objects, right? They have different classes. They're different types of things, right? But those are both objects, where the one on the left is a human, and the one on the right is has a class of class. And that becomes very important shortly. So this is how we made our human, right? And this is us defining a method. If we revisit this human class and we want to define a method, so again, this is a method that is defined on the blueprint for making humans. And when we get to our @human, we can then make a second human. We can have our human and our human 2. And when we get back to these, they can both sleep, right? This is part of the blueprint of what makes up a human. Now, this is defined as an instance method on all of our instances, and we just call it just like that, right? Now, there's this human class. Now, if we had wanted to, we could have defined that method as a class method, right? And what we are doing when we're defining a class method is we're defining a method on the instance that is human. Human is an instance of class, right? And if we had defined that previous method as a class method, then we would be able to call it with human.sleep instead of @human.sleep, right? We have the instance of a human and we have the instance of a class. And defining what we call a class method in Ruby is really just an instance method on this class human, capital H, human. So we have the blueprint over here. We have our humans over here. And now this DNA as a blueprint metaphor, I want to extend a little bit here. And now we're going to talk about koalas. Now, koalas also have DNA, right? These are both things that have DNA. But the blueprint part of being a human does not come down here to koalas. We would need a koala class to define the behavior of a koala, right? And then we would have our koala, and we're going to name him Stabby because koalas are very stabby, apparently. I went to visit Australia one time when I was younger in college, and I had a night with some Australians learning never to drink with Australians. I'm not sure if any of you have hung out with Australian people, but they're not people you want to try and drink with. I think on this night we had a case of Victoria bitters, and then we had another case. And then they said, hey, let's go out to the bars and start drinking. Because in their mind, that was just a warm-up. There were 3 of us, by the way. And don't drink with Australians. But one of the things that they told me during this whole process was that I needed to watch out for drop bears, that this was a variation of a koala that would fall out of a tree and attack you. And this is a common prank on visitors to Australia. So first lesson about Australia, do not drink with Australians. Second lesson, drop bears are not a thing. If you're drunk enough, you may believe that they are a thing and that they will fall out of trees and attempt to stab you, but they are fake. So all of that was distracting you from the fact that things are about to get much more complicated right now. So this is our class, right? And we used this class to talk about koalas and humans. And that is an instance of a class, right? In both cases, a koala and a human are both instances of a class. If we ask them their class, it will tell us class. And a class is an object. So I would liken this to the primordial soup where our DNA came from, right? This is the blueprint for what is DNA. You put the right number of proteins in the soup and out pops DNA. And that's how DNA is made, right? This is the blueprint for how DNA comes to be. But objects, right? Just like classes, they are themselves objects. So we have our instances where we have the humans and koalas all together. And then we have our class, and that's an instance of an object. And then we have an object. And what is an object an instance of? An object is an instance of this thing called basic object, right? And basic object, we're going to go as small as we can and just talk about atoms for now. There are smaller things that are known now. My son tells me all about them as we try to identify the different varieties of quark and hypothesize about what may be smaller than quarks. He's 10, and he's going to understand this entire presentation someday, whereas I, the person who crafted it, do not. Basic objects, much like quarks and everything else we know, comes from this Big Bang. And in Ruby, that is the end of the line for us. That a basic object's superclass, basic object inherits from nothing, from nil. So we can start all the way at the left side here, and we can ask about our class, our instances aside for a moment. If we ask a class what its superclass is, that inherits from object. And an object inherits from basic object. And a basic object, if you ask it its superclass, it'll tell you, I don't have one. That's the top of the line, right? So you have a chain of places where we go and look for things that are happening in Ruby. So this is basically the method lookup chain right here that we're looking at. These are the ancestors of those instances on the left, right? So we start over here with our human and our koalas, and the methods, if they are not found there on those individual instances, we'll look in the class for those methods to have been defined, right? That's our first stop. This is what the instance is, the blueprint defined by class. If we can't find it there, we'll check on object. And if we can't find it there, we'll check on basic object, and then we're at the end of the line. And there's another step here while we're talking about metaprogramming called method missing. And that method missing lookup is basically just going to repeat the whole process again, checking for the presence of a method called method missing. And method missing is a thing that you will often see used in Rails to define a bunch of methods on a thing when you don't want to go and define those methods individually. For example, in Rails, when you define an environment, called production or staging or Jonan's super awesome staging, all of those are just strings, right? We're just making up strings. We put them in a YAML file and it's made up as a string. But there is a feature of Rails in that I am then able to say rails.env.Jonan's super awesome staging, ? Right? I can just ask of any arbitrary string whether or not I am in that environment. And that is a method call on env, on rails.env. That's a method call, but that method doesn't exist. It's not written anywhere. That's one of those features that Ruby's metaprogramming allows you to create. So in that case, what happens is that we go looking up all the way through the chain for that method defined on the string, right? We don't find it, but we go back down again. And when we find this method missing, we say, oh, this is not defined on this class. Then we actually define it and then call it, right, on the fly. So this here, this lookup chain, we could say those are the ancestors of our human here. This is where things might get a little confusing for people. There is a concept in Ruby of a singleton class, and it does not appear in the ancestor chain, but it is in fact the first stop when you go to look up a method in Ruby. So if I can't find the method on this instance, and I can define methods directly on this instance, right? It means I'm not finding the method in the class here, but I can actually override a method on class by defining it in the singleton class for a human. So if, for example, a human says hello, and I would like that same method, that same say method, to say goodbye, I could write a new method on the singleton class to intercept that search. As we go up the ancestor chain, up the method lookup chain, I would find first the method that I had defined on the singleton class, and then I would find the method that I had defined on the class. So the reason this is useful, and it may not be immediately obvious why this would ever be useful, but when you're operating in a world with the Ruby agent, for example, you very often find yourself deep in another application's code base that you don't have visibility into. So there are a few cases today in the Ruby community where you find yourself trying to debug code that you can't see one way or another. If you are trying to debug a library problem, you can just open the library app and read the code, right? We didn't have that advantage when we were working on the Ruby agent. Often we would find ourselves in customer support situations where we are trying to debug application code because it's interacting with our New Relic Ruby agent inside of someone's application where we don't have visibility because they're not able to share it with us, right? They're bound by some compliance rules. They're not able to share their code. And in some cases, it becomes even more complicated by the fact that people regularly monkey patch gems using metaprogramming features. So, for example, I was working with a customer for maybe a week and a half. It's probably one of the hardest bugs of my career, where we were trying to determine how the middleware stack, when you have a request come into any rack-based application like Rails, comes in and it goes through a process of middlewares, right? We start with middleware A, and middleware A does something, right? And then it passes it to middleware B and middleware C, and eventually makes its way into the Rails middleware, and there are many of them, right? And then it comes out the other end, and the request comes back to the user. But the response comes back to the user. But that nesting happens in a very specific way that you're able to understand if you just go and read rack. And you can see how, including rack middlewares, you can include them at different places. So what the new relic agent did is it included itself first, because we want to be able to time that request, right? We would reach into the middleware stack and we would include ourselves first. And in some absolutely mystifying way, what was happening with this customer is that no matter when we added our middleware, they were always first. And eventually, using this approach and other similar metaprogramming techniques, we were able to determine that what this particular customer had done was overwrite rack with a custom different version of rack that had the same API as rack, but they had disabled the methods that we were using to include our middleware where we wanted it to be, and they had used the same version number as another rack. So they had a rack that, let's say, was rack, I know the versions are quite low, I would say it's rack 7 though, right? 7.01. When we were working at rack 7.01, we're looking at the code over here and the behavior over here, and they were very different things, very different, because they had written their own custom version of rack and assigned it the same version number and metaprogrammed away many of the methods, or just, you know, written them themselves in the actual code for their rack gem, and they were installing from their local gem server. So please, please, please don't ever do that. If you're going to make a custom version of an existing gem out there in the ecosystem, make sure that you just leave us a version change or some sort of hint to let us know that this is not what it appears to be. So speaking of not being what it appears to be, I'm going to attempt now to drop out and share a different screen with you. So if I stop sharing and then I go over here and I share again, then this time we're going to be looking at IRB. Hey, look at that. Okay. So now you can see that. You probably want to blow that up because this is going to be a big version. So we're using humans as our example, right? And we, yes, the role of parents, I'm just reading the chat. The role of parents is to be constantly overwhelmed by how much our kids know. I would have, before having children, considered myself to be a relatively intelligent person, but I am regularly lapped by these humans. So speaking of humans, let's make one. We're going to have a class, and that is a human, right? And our human is going to have this method speak. And when a human speaks, they say, hello, right? And then we close our method and we close this. So that's an instance method on human, right? We can actually look at a human's instance methods. And when you use these methods like instance methods and singleton methods, which I'll get to in a moment, you have to say to Ruby that you want only the instance methods that are defined on this object and not the instance methods that would be found through the ancestors, right? So now we can see that human has an instance method, speak. We've just defined that method. It exists on human. Of the instance methods false, right? Now, if we don't put the false here, then we get a lot of other stuff, right? We don't need to care about any of that stuff. This is all of the stuff that human found in its chain as it went looking up through all of those other places that may have instance methods. So we can figure out what that was, where those methods are defined, by saying human.ancestors, right? So if we look at object, and we ask an object what their instance methods are, right? And again, we're going to say false, so we don't want object to look into kernel or basic object. This is just what object has. It doesn't have any of those, right? We can go up here, we can look at kernel. We found those methods, but it's a subset of the methods that exist. You can see it's just a bit shorter. And there are the rest of the methods. So the methods that we have on human minus the methods, human.instance methods, false, minus the methods that we find in kernel, speak here. Okay? Kernel being one that inherited then from the basic object. So we can say then, if we create a new human, we could say human.new. And I lost a line, but that's fine. We can then tell our human to speak, and our human says hello, right? So we have an instance of a human, and we have the class that is a human, and those instance methods that are defined on the class, those are the methods that you would think appear in this circumstance, right? They then become accessible to be called directly on instances. Now, if we wanted to ask a human about its singleton methods, again with false, don't go looking for them if you can't find them on yourself. You have no singleton methods here on a human, right? And I'm trying to think of an example of a thing that a human can do in a class sort of way. Well, we can go extinct. We can extinct humans, and we're just going to put bye, not to be morose, but we may be on the edge. I'm expecting some news later today. The news just keep coming here in 2020. I really hope that this is not the end of humanity. So now we can do this, right? We can say human got extinct, and this really should be phrased differently. I did it wrong, and I can do it here, which was not my intention. But now we're going to have to come up with another example where we do it properly, which is in fact using self dot. Right? This is the way that you are defining the method on the thing. So let's do a different one that's a little bit happier. And we can actually use emoji now. Oh, this is the best. I love that I can use emoji in my Ruby scripts now. This makes me very happy. Okay, that's our cheer up. We're going to put a little smiley face. And now I can say human.cheerup, Jonan, and I have a smiley face, right? So this is a class method, right? This is, in fact, a singleton method, what Ruby refers to as singleton methods. And we could just say false here, and we will see that in our singleton methods. So now our human has two instance methods, and those instance methods, predictably, are speak and extinct that we stuck in there, right? I'm going to, let's see here. Can I do it this way? I think I can. I think I'm just going to undo that thing real fast, this extinct thing. All right, that's better. So now if I ask a human what its instance methods are, now we just have speak. And I just removed the method directly off of human. Right? So this is one of the things that you can do when you start to understand these things, is you can start to grab methods off of objects and put them in different places. So I have a human, and I have those methods. Now this, I've used previously instance methods and singleton methods, but this one here, when I say methods, this is going to give me all of the methods that exist on humans. And you can see cheer up there at the top, but also there's a lot of this other stuff here. So if we want to clean that up, we'll just go human.methods minus object.methods. And now we just see our cheer up method as the one method that I can call on human here. And I can actually, I'm just going to go with C, I can actually grab that method definition directly off of the object. Cheer up here. And now I have this method cheer up. And this method is now relieved of its context there in human. It came from human. So if I made a class called Koala, for example, and I said koala.define method, we want to make it so that koalas can cheer up, right? This isn't going to work. And it says at the bottom here, can't bind singleton method to a different class. So the method is still a human method. It can only be bound to humans. But I can do human.define method happy. I can give it C. Oh, it's a different class. All right, never mind. We're not going to go into that. The point of this method definition here with the class methods, right? We have the singleton class methods of false, and we have the instance methods. I was going down a rabbit hole, I realized, with the binding of a method. There is a way to accomplish the thing that I was about to do, but I will encourage you to look up yourself. We're not here to play with methods. We're going to talk about the singleton class. So our singleton methods, our cheer up and our speak is an instance method, and a human can speak, and a capital H human can cheer up. and we have this thing here. So in that method lookup, you remember we had the egg, right? The egg in this case is kind of loosely this concept of mother, in that I have a mother. It's, I think, the idea of an instance of a DNA almost, right? That I have a mom and your mom is distinct from mine. In this modern world, very thankfully, we may not all have mothers. You may have two fathers. You may have a father. I'm not going to guess at the nature of your family, but I will say with some degree of certainty, you probably came from an egg somewhere in the mix. So that's why we're using an egg, right? But the egg that you came from is distinct from my egg, even though they are both human eggs. And the reason that is relevant in this case is that our human, our instance of a human, actually has something else in its lookup chain. And that is an instance, an anonymous class, right, created to manage behavior for just this instance H of a human. So I can ask this Singleton class about its method, about its methods. And we're going to take away the object methods. And I have cheer up defined on my Singleton class. Okay? And this cheer up is in two places now. So if I have a method called cheer up on human on the Singleton class of human, then I am able to call it on the class of this human. So I can call this, right, cheer up, and I'm going back up to that smiley face, but I can intercept that message. So in the instance method case, let's start with that one. I say speak, and I have hello. And on the Singleton class now, I'm going to define a new method. And this is a thing you may not see very often in Ruby, but I'm just going to define another method here specifically for this class. I'm going to say wolf. I'm going to say stab, right? I'm going to slowly permute my human here into a koala, into a stabby drop bear. And I end this here. And now if I say h.speak and I see stab, because I've now added this stab method onto the Singleton class, instance methods, instance, there we are. There are many things defined here. I'm gonna look at these. And there's our speak, just on the instance of our Singleton class. So this in the lookup chain, in our method lookup chain, this sits between me as a human, as an instance of human, and my class definition of human. So there's a speak defined on class, and there's a speak defined on the Singleton class. Singleton classes are sometimes called meta classes in other languages, or eigenclasses. The generic term eigenclass for mathematics refers to this egg concept that we're working with. But again, I can look at my human ancestors, and I don't see this thing appear anywhere in this list, right? Like I would a module. If I included a module, I would see that module come after human in my list of ancestors, and I could include a module, and I could prepend a module. I would see it come before human, but you don't ever see this Singleton class in your method lookup chain. But the reason that it exists is that now I'm able to say, this H will speak, this is stabby, right? And then we're going to make a new one. We're going to make an H2. And this is a new human. And this new human has the original implementation of speak. So I can customize the method definitions for individual instances of my objects. In the case where we were trying to debug that rack problem from earlier, we used this technique to attach methods and override method definitions on the object that we knew were supposed to be doing the right thing, but they were in fact not. And by doing this, we were able to basically replace the functionality of rack so it behaved as we expected it to, and get back to a place where we came to understand the nature of our problem. So This is occasionally useful, but not something you need to dig into so very often. It's just important that you understand that this singleton class, if I look back again at our singleton class, this singleton class's methods, they include cheer up. Those methods that you're defining when you're saying self dot in your class, those are methods on this singleton class. They are part of the blueprint from which we make the egg. And those are on the instance, the anonymous class that is the singleton class of human. So earlier I was speaking with someone at one of the tables before these talks started, and I was explaining this idea by saying, by talking about the singleton class and metaprogramming features. They said, no, I've never used that, but you're in fact using this every day. And by understanding a little bit more about it, you will make it much more useful to you. So I encourage you to get in there and play around with singleton class. If you really want to try and extend your knowledge, then I want you to go in and play with the including and the extending and the prepending of modules and where that fits into this method lookup chain as well. So I'm going to go ahead and finish up here. So I have a couple of minutes for questions that I will attempt to be able to answer for you, but I make no guarantees. So I will drop out here of sharing my screen and be watching the chat carefully. Or not. No one is here.
Hello.
Here we are. Hello.
You're surrounded by Bens, or not just one Ben. Okay, so we have one question asked in the Q&A, which is, you might have hinted at it, but maybe flesh out a little more. What's the priority of hierarchy? So an instance would override a singleton method and things like that. Like where is the hierarchical order in those things?
Right. So the way that we go to look up the, oh, did you just clear the question? That's a nice
did.
feature.
Yeah, it's a good feature.
Okay. So when I have my human, the H in this case that we were working with that entire time, and I define an instance method. When we first opened up class, we defined an instance method speak, right? And speak said hello. But if I then go and take the singleton class, which is created, it's an anonymous class that is created in a pair with that human instance. We created H, we said H equals human.new, and at the same moment, this singleton class came into existence. Right? And we're imagining that because it doesn't actually come to exist until we reference it, but we don't care about that for now. So you have this H, and this singleton class appears, right, from the ether. Then we have an egg, and the human comes out of it. And from that moment on, that egg sits in the method lookup chain directly between the human, the H, it would go H, egg, human, the class. So all of the instance methods that we've defined on a human can be immediately overridden by adding those methods to the singleton class. It will intercept any method calls as it goes looking up. I hope
That's really interesting. I hope that answers the question. If it didn't answer the question, you still have time, whoever you asked it, to ask again. I'm also interested in, so this whole model of singleton classes, we actually are, as you discussed it, it's not so utterly unfamiliar, right? We do see it. And I'm curious, like, if there's places where you see this implemented in some common Ruby libraries or places where they use it a lot. I think Rails uses it a lot. If you could talk a little about like where we might see some of these things in live code.
Right. So you'll see a lot of these in a lot of working with the method lookup chain, at least inside of Rails, from the olden days when you would be using a module in multiple ways at once. Nowadays we have prepend. Prepend is a new feature of Ruby. So we were talking about I was just distracted by a pop-up. This is good news. We've extended by 30 minutes. The modules, when you include a module, you'll be able to see it appear in the in the chain of things that, in fact, here, hold on. Am I able to share this
You definitely can.
window back again? I'm going to share this again.
Now you're a sharing expert.
I'm sharing. I'm so good at computers. Look at me go. Okay, let's just make a new class entirely here. We're just going to call it foo because everyone calls it foo. And then we're going to make a module, and we're going to call this one before. And we're going to make another module, and we're going to call this after. And now when I look at foo and I ask it what its ancestors are, then I go foo, then I check object, kernel, and basic object, right? So now if I reopen my foo class, I can say, foo, I want you to include any methods you find on after into our lookup. And now I can ask foo about its ancestors. And you can see that after comes after foo. So any methods that were defined on after, they will now be found only if they are not found on foo. Right? If foo has a say method defined or a speak method defined, it will find it on foo before it finds it on after. But this new feature, this prepend feature that is available in Ruby as of Ruby 2.0-ish, I think. I think it was actually a Ruby 2.0 feature. Now I can prepend the before onto my class. And now if I ask for my ancestors, you'll see that before comes before the class definition. So in that case, any methods defined on before would override the methods that I had on foo. And this used to be a thing that was more difficult to accomplish. And additionally, Rails likes to do a thing where a module will add both instance methods and class methods to a class where it's included. So if I have this before as an example here, I'm going to say before, and we are going to define a method say, and I put hello. And now I can call on a foo say, and I get this hello. But I can't say foo.say, right? In order to do that, I would have had to open up my class foo and extend this before was the one we reopened, right? And that adds the class here. So now I can say foo.say. So in some cases, the Rubyists who were working on Rails at the time wanted to define both class methods and instance methods with a single include call, where they did some very interesting things with a method called the alias method chain and a hook that appears in module. There are a number of Ruby hooks as you get deeper into metaprogramming. Oh, and I have a book to recommend on this topic. So let me drop this share screen so I get a bigger. This is the book by Paulo Pereira, Metaprogramming Ruby. And you can see the Escher staircase. That's your brain on metaprogramming. It's a fascinating thing to study, but it is really, really easy to confuse yourself. So take your time. I myself am still very often confused, but this extend and this include and this prepend, there are hooks for all of those so that you can actually run some code as soon as a module is included. And then in the case of what Rails does very often is after a module gets included, it will then find the class methods on that module and define some of them on the class so that a module being included can define both instance methods and class methods.
I think the theme for this evening between you and Ariel is to basically make people's head hurt a little bit. So I appreciate that.
Bit.
Just a little bit. It's very helpful. We have two more questions that came in. One is, do classes themselves have singleton classes?
They do, because they are objects. Because
everything is an object.
Everything's an object. And there's one singleton class to rule them all, and that is the nil. It's at the top of the hierarchy.
The nil class.
Fact, yes. You can ask nil what its object ID is, and it will always be the same. And it's the same for any constant in Ruby. You can ask numbers what their object IDs are too, and they'll be the same. That's different than asking H or H2 what its object ID. That'll be a new object ID every time as new memory is allocated. But nil is always 4.
Interesting.
Sometimes you'll get an error in your applications that says unknown ID 4. You're probably looking up the ID of nil.
You know, I've actually experienced that recently in some code. I'm not going to go down there right now. Next question. Although I have some experience with metaprogramming, I'm always not using it because I'm afraid it's not clear to others and it's implicit instead of explicit. do you have some good tips on basically how to address some of that implicitness of metaprogramming?
Yes. I can see that maybe you have studied some Python in the past, or maybe you would enjoy Python. Python, by definition, is an explicit over implicit language. And if you think about what that means from a conceptual level, what we're saying in Ruby is that it's okay to make some things happen in the background if it allows you to abstract away complexity from the people using a library. So, oh yeah, was nil a typo? Should be 42. I like this. It's actually 8 now, apparently. The object ID of nil is now 8. But I don't know when they caught up. The question you were asking about implicit versus explicit is generally understood to be an okay thing in the Ruby community, that if you are simplifying my life when I'm using your project, as the example from Rails earlier, where we were talking about the string, where I can just define a new environment. I can define a new environment called Jonan, and I don't have to do anything extra to make it work so that I can say rails.env.jonan ? Right? I have that predicate method automatically defined for me. That is a perfect use case for metaprogramming. And many people coming into the Ruby community from the outside, they're very frustrated by this. They say things like, Ruby is magic, Rails is too magic. And I would argue that maybe what you're instead saying is, I don't want to be bothered to look at the code. But if you don't want to be bothered to look at the code and you demand explicit languages, then you're in a situation where every little piece has to be out in the open. And from my perspective, if you want that kind of visibility into what's happening in your code, you may as well be writing in binary. If you're expecting to see that level of detail and understand in every moment, and I appreciate wanting to understand things, this is what fascinates me about metaprogramming. But there are days when I just want to ship. I just want to deliver a thing. And I got to say, to this day, 10 years in, I have not found a framework in any of the languages that I now know that is more productive for me than Rails. It just doesn't exist.
So I would love to ask you a question that I think is an opportunity for you to pontificate, actually.
Oh, well, that's hard for me.
I know. I can tell you don't like the soapbox at all. The question, I think, naturally leads from what you just said, which is, as you know, in the Ruby community, we're facing sort of an inflection point as Ruby 3 comes closer to arrival, which is around the issue of strongly typed Ruby or static typed Ruby, and the implications of that for things like metaprogramming and the explicit nature of the code versus the implicit nature of the code. So just to give a little bit of context, us in the Vonage / Nexmo community, so in our Ruby SDK, we've been slowly adopting typing in the SDK. And we've been doing it loosely, meaning we're trying not to change as much of the code as possible and type what's currently there. But as we go to next stages and make it more and more explicit, it's almost by definition going to run in conflict in some ways with what has been so beautiful about Ruby in so many ways. But we're doing it because there's other benefits, like everything. It's like a cost benefit analysis. So I would love to hear you get on that soapbox. So where do you see this going down the pike on the metaprogramming question?
I have a lot of thoughts about types in Ruby. I am a big fan of the choice that Matt's made to go with duck typing. We call it duck typing, the current implementation of types in Ruby. We call it duck typing because if it looks like a duck and it quacks like a duck, it's a duck. And that encourages us as programmers to think about the behaviors we're trying to define. So if you're familiar with test-driven development, there's another layer called behavior-driven development, where I'm forced to think about what behaviors I actually have on these objects. And if I have a human and it speaks and it says hello, and I have a koala and it speaks and it says hello, then why does my other object need to care whether it's talking to a koala or a human? And I am a fan of that. I think that that's a very simple way to view the world. And that implicit nature of those kinds of behavior-driven design principles, like from object-oriented design perspective, that's not ideal for certain worlds of programming. For example, checking accounts. It's not great to maybe not know if you're talking to a dollar or a koala. And this is why we've started to see type systems pop up from companies like Stripe, where they created their own type system that you surely are remembering the name of. Hit me.
Sorbet.
What's that? Sorbet is the thing. Yes, I recently had sorbets, some sorbet maintainers come speak at PDXRB. But the drive for that kind of typing is important, I think, to a subset of all Rubyists. So my case would be that for the majority of us, it probably won't change very much. They're going to implement type definitions as separate files that you can include in your Ruby application.
Right. In Sorbet, they're calling it RBI. I think in Ruby 3 it'll be RBS. It's interesting it's coming from Stripe, right? Because that's like almost API-driven development. And when you're working with something as like a checking account where a dollar needs to be a dollar and an API where an integer needs to be an integer, you're running into walls, right? And you need to be able to interact with the thing you need to interact with. But that's like as you said, a subset of developers. So that's actually a really interesting perspective of it.
I would like to see those type definitions simplified. I think that there is a world where we as a community are able to bridge the gap. So we have these RBS files now. Sorbet uses RBI files. They're going to catch up and start using these RBS standard. They're in communication with the Ruby team. But that someday there's going to be some bridge there that just happens for me and abstracts away this type thing. And maybe the first time that I run my Ruby code and I pass an array into some method, that it generates its own type, some tool that I can use almost like a linter to just generate the types for my application. And then I can carve those in stone moving forward. So
I'm sure we can make some YAML config file to help solve that.
Yeah, I look forward to it.
Are there any other questions in the chat? I don't see. I see some interesting comments about Ruby playing God. Okay, if there's no other questions, Jonan, this has been fabulous. Thank you so much for joining us. I'm going to move us back into the tables for the last few minutes of schmoozing, discussing, hanging out.
I'll see you at the tables discussing and hanging out.
Okay, talk to you soon. Bye.
Okay. Bye.